7 minutes late.
Great. 7.
7.
Exactly 7.
Yeah.
Okay.
It's like kind of.
It's the 5-minute delay plus the 2-minute delay, 7 minutes.
I see. Yes, in the different tabs. Every agenda item up with the different tabs. It's not like it looks strange on the screen sometimes, but well, okay. So I can start circulating those things.
Brian, I propose that you ran the research group to the optimization aware networking.
The standard diagram population aware networking.
Yes. Something longer, please. Not yet.
DPLPMQD, 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 DPLPMQD. Boom, like 5. Answer stands to my record.
Am I allowed to keys?
Yeah.
No, we have open mic time. So you can exercise during the open microphone session. Jam session. So, shall we start? Hello, Friday morning. We appreciate that you are here. So this is Passover Networking Research Group, actually.
Yeah, we're not.
I cannot update the slides. Great. So I hope you are in the right room. Even if you are not, please stay. What could be more interesting on Friday morning? So, note well, it's almost like airline security procedure, right? You're supposed to pay attention every time, even if you fly often, but you still don't. So yeah, note well, it's on the slides. Okay, we have agenda. Oh, we have 10 minutes for charter discussion. Oh, first of all, thanks Teresa and Tommy for being on Jabber and for taking meeting minutes. Appreciate it. So, shall we proceed with next? Okay. Yeah, we have 2 documents. No, I know the chair is supposed to talk about documents, right, in the beginning. So we have one group document, your document, which was adopted, and there is another. Spencer? Yeah. Okay, so we have 2 documents, and now we can start talking about charter. And I'm going to give you a microphone while I'm switching slides.
Yeah, I'm actually going to do that. I'll do it up here. Actually, no, this is my chair. I'll do the other one.
Okay.
Right, so after, yeah, you got to click that thing and then it works. Yes. So after our last meeting, which, if memory serves correctly, was in London, we had a few sort of short comments about the charter, the scoping. None of these changed the work to be done in the research group fundamentally in any way. But we wanted to basically, get the charter in a shape for no longer being proposed. We actually there was a discussion in the IRSG right after London about whether we were going to be, whether we were going to stay proposed or not, and Allison basically said, good, congratulations, you are now a real research group. Just update the charter, and then we forgot to update the charter. So then we ran an analysis and it was like, oh, well, okay, Jen and I are going to have to set up a meeting in order to finish updating the charter. And then I realized that we'd already had that meeting on the side of a right meeting in Marseille, and just nobody mailed anybody afterward. So I took the content of that, stuck it in the slides. Is there do we have the thing of what's, there it is, are these? All right, so we have some eye charts. The preamble hasn't actually changed. Basically, the point of this is to frame why we're talking about packetization layer aware, path aware networking. Tom, come on, there you go. Basically, the difference between, if you're talking about a research group that's talking about, changes to the internet architecture, you have to talk about what those changes are, and that's the point. here. It's like if the path is, currently we make this assumption the path is invisible, it's homogeneous, it's singular, the dynamics are determined by the connectivity of the endpoints. There's been a lot of work, for example, in the transport area that talks about, the properties of the path that really means the properties of the adjacent link, so on and so forth. And we want to sort of tease this out a little bit, and that's the point of this research group. Why now is increased diversity in access networks. The internet is primarily connected at this point over various mobile access technologies. If you're looking at the internet user population, the fact that many of these are multiply connected means that we have multipath protocols. What happens if we go one step further and take this implicit ability to do path selection and turn it explicit? Anybody who's listened to me talking to Mike at the IETF anytime in the last 5 years know that explicit is my middle name. So it's okay, but let's do this at the path side. So this research group aims to support research and bring internet path awareness, transport, and application layer protocols, bring this research in space to the attention to the internet engineering and protocol design community. So that's what we are here for. Does anybody have any comments they'd like to make on this? Right? I mean, like this would be like sort of a research group scope changing thing right now, so I hope not, but we are here to discuss, and we have about 8 more minutes and 3 more slides. Good. We have, Chris. Hi, Chris.
Sorry, hey, Chris Wood, just a quick question. Are any privacy considerations going to be considered in scope?
Hold on, look in the scope. I mean, yes, obviously we haven't written it down.
Okay.
If we'd like to write it down, I think we want to write it down here. Like not this slide, but this slide.
Yeah, that makes sense.
Yeah. We haven't actually sent this up to Allison yet, and I don't think she's here. I think she left a little bit early today. If somebody can hack the data tracker. Oh, here comes an area director. Area directors can hack the data. Then yeah, so if you can propose like a bullet point here, that would be good.
Yep, will do.
As an individual, not an area director, something to add on this, I think having like some kind of also assurance, that's probably a hard word, about like what the path is, like knowing afterwards that you actually took the path that you wanted to take. That's like one of the main privacy and privacy aspects. So
we talk a little bit about like, so that's this exploration of trust and risk models in that first bullet is doing a lot of work. That's where both of your questions are hidden. But yeah, teasing it out and making it more explicit in the charter is fine, right? So the side bits here, right, are basically pointing out that we have a couple of documents, and the bottom point is explicitly addressing, or is explicitly addressed by Spencer's document, and then an elaboration of the top 3 points is in Panrg questions, which I'll get to next. It turns out that we're kind of a transport-heavy research group, but we're looking at sort of architectural questions that originally came up and looking at evolving the transport layer. So we have a lot of sort of coordination to do. One thing that we've done a bad job of, we talk about it here in terms of like routing architectures, supporting some notion of path or path properties, right? Like so Lisp, Spring, things like that. I think there'll be a lot of overlap between what we're doing here and say V6 segment routing. You could potentially implement a path-aware internet if you built a interdomain routing protocol that could do interdomain segment routing, for example. Right?
Yeah. Börje Johan Eriksson. I just wonder, you don't mention Lisp, but no, sorry, not Lisp, Alto. I was up here. I think that would be relevant.
Right. Yeah. So this is a include but not limited to. But if you want to give me a so I mean, we've already had like the Alto people come to a couple of these, so we are interacting with them. If you want to list Alto here, then
I think
then
so,
send me a bullet point.
At a very high level, what you're trying to do seems to be very similar to what Alto is doing. So I think people will wonder if it's not there.
Yep. Yeah. So actually, yeah. Given the history there, we probably should have a bullet point there. Can you send a bullet point to the list and we'll add it? Thank you. Yeah. So one thing that we've done a bad job of is not scheduling against working groups where the entire routing area has to be? So are there any people here who consider themselves IETF routing area people? Okay, so now we've scheduled against the flights of the routing area people, which is also not great. So this is a thing that we need to do a little bit better job of. Meetings, we meet at the IETF. We commit to co-locate with one IETF meeting per year. We can meet between 1 and 3 times a year. We may also bridge the gap between internet standards and measurement communities. Actually, that should say measurement and other research communities, right? So we've, last year, we put in a proposal to do a co-located workshop with SIGCOM, which was turned down because they're like, okay, well, that's great, you're the IETF, but, you know, what are you really doing? And, great. So as we go forward, we're going to continue thinking of venues, what would be appropriate for co-located workshops or meetings. If anybody has suggestions for those, please bring them to the list. But I suspect that in the intermediate term, we're primarily going to be a 2 to 3 meeting per year research group that's primarily at the IETF. That is the charter. I heard 3 suggestions for change. Please send, even just like one-liners to the list, and we will put those in before we send this up to Allison to get the charter text changed. Any other questions on the charter? Excellent. Thank you very much. And now I stand up, right? Check, check. Oh, this one is a little bit less hot, so I'll have to eat it. No, this is, yeah.
Okay.
No, it's good. No, it's good. I will put this back down there. So like this. So, hi, Brian Trammell now speaking, not as co-chair of the research group, but as an individual interested in this space. Going a little bit beyond the charter, I decided to kind of write down what questions have come up, at least sort of in my thinking about the space. We've discussed this document a few times. We've had pretty good feedback here. It's adopted now. At the end, I'll ask kind of what we should do next, but first I'll go through the questions very quickly. If you're talking about a network that is aware of its paths, you need to have properties of these paths, and these need to be defined in a way and represented in a way that they can actually be used either in routing decisions or forwarding decisions or connection decisions or all sorts of different places. So how do you define and represent those? How do you get access to trustworthy path properties? I think these are hard questions. So those of you who remember the path that shall not be named, we looked at this and a lot of the opposition to the idea of having the endpoints talk to the path turned on the danger of the type of the things the endpoints might say to the path about the path. Right, like, so you don't want to have path properties where the path property is, this is a path that is acceptable for subversive political content via video, right? Like that's useless for networking, too specific, and has like horrible human rights implications. So we don't want to do that, right? So what kind of like, on the other hand, there are things that are pretty uncontroversial. So paths have latency associated with them. They have loss. They have lots of things that we've known how to measure for a very long time. And then there's stuff between there, right? So how do we define these? How do we represent these? How do we get them into the system? Sometimes that's the path says things about itself. Sometimes that's the endpoints do passive or active measurements of the path. There are a whole bunch of ways to do this. So questions 1 and 2, I think, are kind of our next assignment. Beyond that, once you have information about the path, you need to be able to use the path to figure out how you're going to do the work of networking, getting packets from one place to another more efficiently or better or cheaper or, wherever you're doing this optimization. So there are mechanisms for path selection, right? So right now the mechanism that we have for path selection is you put in a destination address on it. And of course, as everybody knows, all packets destined for the same destination address always follow the same path, haha. You know, and the idea is to make that a little bit more sort of explicit. When we started writing down these open questions, it wasn't really clear that questions 4 and then on the next slide, question 5 are largely going to be addressed by the TAPS working group and the IETF. So we're kind of going to say that's not really in scope for us to work on here because we have a place to work on that. Interfaces, transport applications support the use of path awareness. So the TAPS API has an explicit notion of path selection. At this point, it's primarily based on address family racing or interface racing. But if you took that infrastructure and stuck it on top of a network where you could actually do path selection, it's sort of trivial to show. Like we have this path concept in the TAPS architecture. And then how you have to redesign transport higher layer protocols. So this is work that was adopted in the TAPS working group at the last thing. So I think that we should just sort of, as a research group, get out of their way and let them do stuff. And when I say them, I see most of the TAPS people in this room. So I mean us. A good question actually came from some of the Alto people. How does any of this change? Like, you know, the original questions were posed in the explicitly in the charter with respect to end-to-end path awareness. The server endpoint knows how it's going to get to the clients. The client endpoint knows how it's going to get to the servers. The peers know how they're going to connect to each other. All of this information goes all the way down to the end. A lot of the work in this space. So we had presentations 2 or 3 meetings ago from people who work on Scion, which is a path-aware networking architecture, where the way that usually gets deployed is tunnel endpoint to tunnel endpoint, right? You're not rewriting the applications to this new infrastructure. You basically, what the architecture gives you is basically a really, really nice VPN. How does all of this work change when that is sort of the explicit goal of the work, right? How do the path property vocabulary change? How do the operations change? How do the interfaces change when it's like endpoint to tunnel end or tunnel end to tunnel end, right? Questions 7 and 8 or layers 8 and 9. And these are like sort of, these were also raised on the list in early discussion. How can you effectively operate a path-aware internetwork, right? So right now, network operators, they kind of have predictable, in air quotes, behavior that comes out of announcing BGP routes. You're doing interdomain traffic engineering through BGP on a per prefix level. You're making an assumption that all of the traffic in a flow is going to flow the way that your BGP and that your interdomain ECMP is distributing that traffic. When your endpoints now have the ability to control exactly where their packets go, all of that traffic engineering knowledge and control kind of goes out the window. And you set up, in the worst case, an adversarial situation, right? How can we avoid that? That is a sort of a research question in network operations. It also tends to be a little bit of a research question into incentives. And that's the 8th one, right? Like how can we align the incentives of all of the various people who could benefit from this architecture in such a way that it actually gets deployed, right? These, I think, are listed in order of increasing difficulty. At least that was the intention when I put the thing together. It's like, we're going to start with 1 and 2. We're going to leapfrog 4 and 5. We're going to have to do some work on 3 at some point once we can expect that'll be useful when they're routing people onto airplanes. And then we'll get to 7 and 8 once we've been successful in showing that the technology can actually work. Yeah, so what's next? Begin answering for questions from the top. I think that's the right thing to do. As I said, I sort of foreshadowed this. We have, I think we have, and we'll see a little bit in Spencer's presentation next, we have some information about what properties might bind to paths, right? So we're not starting sort of off in the woods. There's been a bunch of work in this space before, and we can sort of collect it together and put it in a big pile. And we can look at the ways that path properties can be disseminated. I mean, a lot of this stuff is also stuff that Spencer's document is going to talk about ways not to do it. And part of the hope here, right, like this is a research group, because if we knew what we were doing, it wouldn't be called research. Part of the hope here is that we can sort of look at the set of possible ways to achieve path property dissemination, and all of the ways that Spencer is going to tell us don't work because we tried them and there was a horrible failure and a big crunching noise, and we subtract the one from the other and we don't end up with the empty set. So I, as an individual, would ask if there is anybody interested in these. We should probably get a group of people together as potentially interested co-authors and, you know, try to get stuff going. So if anyone would like to, oh, okay, cool. If anyone would like to come to the microphone behind Teresa, please do so.
Teresa Einhardt, TU Berlin. I have been doing some research on characteristics of access networks, and that implies sort of characteristics of the paths. And mostly they are per interface right now, but I'm like trying to gather information about what is basically the path from a host perspective. And I would like to collaborate on a document addressing question 1.
So that's you volunteering.
Yeah.
Yay! Anyone else want to help? Johnny.
Yeah, no, it's a very interesting working group. I'm very excited about that.
It's a research group.
A research group, sorry. Yeah. Just a bit concerned. I just want to have a use case here to see if I got it right. So let's say you have an end user that have multiple, with multi-home can choose from two different interfaces, and you want this end host to make a choice from end-to-end path, which end-to-end path to choose, what is the best for him? Is that what you're trying to do?
That's like sort of like in the crazy vision, that's phase 0, right? We're kind of there already in that, so if you're on many mobile devices, if you're multiply connected through LTE and Wi-Fi, there's a policy that's usually pretty crude that says, hey, I'd like to minimize my cost.
Yeah.
So I'll use Wi-Fi first and then LTE, or there's like, I have an iPhone and there's this thing where you can like, your hog applications, you can say you're not allowed to use the mobile interface and things like that. The further vision where I want to get, the crazy idea that this is all behind is I'd like to be able to do the same kind of multipass stuff, even when I'm only singly connected. Okay. Right? So you can do this right now. Like the cheap way to do this is you take your home router and you give it like 7 VPN tunnels that all exit in various IXPs, right? Like you can build a cheap thing with a home router, some firewall rules in AWS, right? And if you take that information, you give it to the transport protocol, it could do things like flow spreading, right? So there's traffic analysis resistant stuff in here too. There's like a lot of things that you can do with this once you are no longer tied to the idea that a single flow maps to a single 4 or 5 tuple maps to a single path for the life of the flow.
Yeah, but is your vision like every end host would have a path, would have path information about every destination you want to contact? Would it be an overhead? That is the vision for the virtual interface. That's what we'd like to get. Like actually implementing that in the naive way of flooding end-to-end path information all the way down to every end host, where you have path diversity on all of those through different networks on a per hop basis is clearly unscalable, right? But you could have, on the other hand, right, like, so the thing that might scale is, again, this hack that I just invented with the various VPN tunnels. You could do something else where you put tunnels together. I mean, like, so you could say that Tor is, for example, is a circuit-oriented path-aware networking architecture that has as its primary goal anonymity, right? But you could put these sort of like subsegments together in ways to do other things, right? So the one thing that's actually missing probably from this, from this, I wouldn't call it a paper because it kind of is, but from this draft is a few pointers to research that was done in this space, especially last decade. So this was pathlet routing and everything that cited it for that like brief 2 or 3 years that people are really interested in pathlet routing before we don't see how to deploy this. Well, 2 things happened. One, a lot of this routing research, the source routing research, was stimulated by the idea that the routing table was going to become unscalable, and then and then Moore's law caught up. And then after Moore's law caught up, it was well, you're going to blow up the internet, but we don't need to blow up the internet because we can just buy more TCAM. But so a lot of the concepts that they started working on there are, I think, really interesting. So we're a little bit, we're trying to revive it. This document or something else should actually cite that work as a little bit of background to show how, you know, the beginning of this sort of genesis of this idea. So actually, if who's taking notes, please give me an action item. Good work. Thank you.
I think Spencer is in the queue. Do I need to press the button? Or?
Yeah, beam in.
Okay.
Hello, all.
We good?
Hi, Spencer.
I had two questions. The first one was on your bottom observation there about new document. Were you thinking that that's a new document to contain questions, or new document to contain answers?
I would hope it would contain answers because we already have the questions.
Okay.
I mean, I guess we could ask more detailed questions first, but
Yeah. So the way I'm reading that is basically new documents that are for the answers.
yeah.
Okay. Yeah, sure. My other question was, you had one of my working groups names by items 4 and 5 in the charter, or in the questions. How much of those do you think is still research?
So 5 is more research than 4. Right, like so for people who aren't, so this is a little bit of inside baseball, I guess. So I'll explain some of what's going on in TAPS. So TAPS is basically building a, now as we found out this time, a standards track interface for doing protocol stack agility, which it turns out is actually something, you can think of it as a generalization of happy eyeballs, right? But in a more challenging environment. And that stuff, I think we pretty much know how to do. We actually, and there's shipping code in this. So how can these layers support the use of, here is like sort of, you can't see what I'm doing here, sort of like stack awareness. And it turns out from the standpoint of the API, stack awareness and path awareness are kind of the same thing, right? You have these entities that you could compose in order to be able to get connectivity, and they have properties, and whether those properties come from the implementation itself or something that the implementation measured is really sort of irrelevant. So I think that 4 is pretty solidly in TAPS, and it's pretty solidly not research. I think that 5 is like, how do you redesign the whole stack above is sort of in the interface work in TAPS, that's the first building block of that, but there's other stuff that has to happen above, I think. So that might be a thing that I would say we should throw over the fence to TAPS, and then TAPS can throw back over the fence at us when we figure out it's too hard.
Excellent. Thank you. Thank you for clarifying.
Thank you. See you in a bit, Spencer.
Stu Card. This goes to questions 2 and 3. I think we should not be too quick to decide what are and are not appropriate path properties to be able to report.
Yep.
Because I'll give you an example, real world from about 10 years ago. We were IP enabling air-to-ground communications for aircraft, where historically each application was tied directly to a particular communication system.
Yep.
So if you were doing a particular application, you intrinsically knew what comm system it was going to go over. And we were inserting network layers in the middle. There was a particular, well, this was for a military user, and there was a particular communication system involving satellites where by international treaty, fire control traffic could not be routed over that communication system. And as we inserted network layers that hid from the user what communication system he was going to be using, we had to take care not to route fire control traffic, or we would have had a treaty violation.
That is an interesting story. Thank you for, yeah, so I would, I'm going to put my chair hat on for a second. I would think that whatever document comes out of questions 1 and 2, like I don't think we're at 3 yet. I think that whatever document comes out of questions 1 and 2 definitely needs to consider, we need to focus on the internet case, but it also definitely needs to consider other than internet cases. And I would expect that to be open for sort of a long time, right? This isn't a thing that we like, bang out in 6 months and say, yay, now we've solved the path properties problem, and here is what will go on forever and ever, right? Like, I don't think that's I think it's probably a longer effort. But thank you for the, shaking us out of our internet complacency a little bit.
Tommy Polly. So on kind of just Spencer's points for questions 4 and 5, or 4 first. Right, I agree that 4 definitely matches what we're doing in TAPS. I think there are definitely parts that are researchy that we don't cover there yet. So the basic way of how do we interface with this, we have concrete ways of doing this today for like, oh, this is the access type, this is if it's metered or not. But I think there will be areas in which we can probably explore research here for that.
Yeah, I'll point out sort of the interface definitions in those documents are hand wavy as hell right now.
Yeah.
And we need to rewrite them.
Yeah. And then for number 5, I'm almost wondering if that's less TAPS and more a job for the things that are going to succeed MPTCP and MP Quick. Because right now they have some ability to do very basic protocol adaptations to there, but we haven't probably explored in those groups what are the ramifications of when we have many, many more links and many more things to actually do the scheduling over.
Yep.
So
I know that there was Laurel Schwa who came to this meeting a couple of times ago. He did a little bit of research on multipath per packet scheduling in a path-aware transport layer. And he basically found that the scalability of making a choice was such that if you had one path, it was trivial. If you had 2 paths, you could do it. If you had 3 paths, you were screwed, right? So like reducing that actually is maybe an open question that comes back in and goes onto this list, is like specific transport scheduling, like the specific transport scheduling problem, because I think that if you throw some brain at that, you might get that scalability down, so more than 2 is feasible. Write that down, Tommy. You're taking notes, right? Thank you, sir.
Giovanni, dear Delta inside in. Maybe that's too soon, but do you have given any thoughts on dynamic paths and asymmetrical paths? So, for example, if you send a package from host A to B on the way back can be totally different, and the route can change in between. So maybe that's too soon, but like I just want to raise that.
Yeah, so I don't know that that's like a headline question, but it probably needs, in the description of these questions, we need to point out that paths can be asymmetric, right? Like, so I know that, I think it was Pathlet, like specifically said we're not going to bother with symmetric routing or asymmetric routing because it's just too hard. I know that Scion also did the same thing. Like the way that it does route dissemination is we're just going to, we're going to pretend that asymmetric routing doesn't exist and we'll add it later. So yeah, we need to actually, that's a good point. We'll add that to this document. Thanks.
Right, thanks.
Yeah, could have been. So listening to the conversation, I'm wondering if your assessment that we have to start at the top and then end at the last question at some point is actually correct. So
I'm sorry, can you speak up a little bit? The acoustics
yeah, I'm wondering if your assessment that we have to start with those questions at the top and then we end up at the end at some point, if that's correct, actually. So the first question might be actually the first question. You first of all need to know what a path property is to do anything with it. But the other questions are a little bit more independent.
Okay. Are you volunteering to write a document on path independent transport scheduling?
What's that?
So close.
No, and so I'm wondering if like there are actually 2 choices. You could actually either focus on those questions which are not addressed by any other working group, especially, or you can focus on those that are actually like related to other working groups because you think they are more important. But I think that's also another choice to make.
Yep.
And then all your questions start with how. And I wonder if you actually just want to work on the how, or do you want to work on the what? So like for path properties, do you want to like list path properties, or just want to explain how somebody can understand if the property they're looking at is a path property or not?
Yeah, so the how here is, I think that is more editorially intentional, and I think that's a mistake, actually. I wasn't thinking, hey, there's this vision and it's very, very clear and we just need to figure out how to do it. I was thinking more, yeah, it's like, this is, yeah, right, like path property definition, question mark, path property access dissemination, ... question mark, right? But like so these are the just literal quotes from the last sentence of each question section in the document, and they kind of do make it seem like these are how questions, and they actually aren't how questions. That's a good point.
No, I mean, like, I'm asking about the scope of working. Do you rather want to document what the different options are, or do you actually want to work on a specific option and drive it?
I would start personally. I don't know. I mean, we have a volunteer, so maybe we can ask Teresa if she has an idea here. I would start personally from documenting what's been done before. Start with Spencer's document. Taking in mind, especially there's a section that he has of like, these are the things that we've learned. Read that, take that to heart, and then look at work that's been done and try to see how the stuff that's been done doesn't fall into the traps that we've fallen into, and then go from there. That would be, because this is not, I see this whole path-aware networking thing as a new way to frame a lot of very old questions. So there's a lot of stuff out there that we can draw from, I think.
And then slightly separate point, question 2 is actually, I'm not sure if you said this already, but that's very related to Alto. It's only one solution to get information about the past, but it's like one solution that's actually standardized in there and usable.
Yeah, so we actually had some Alto people come over, I think 2 meetings ago. We should maybe devote a bit more time at some point to sort of like reframing the output of Alto as an input to this. If we could, are there Alto people here? They're also on airplanes. Okay.
Lin Han from Huawei. I don't know if you want to cover the new architecture for multipath. That current solutions such as Scion and Nira Pathlet or not deployed.
I'm sorry, can you, the acoustics here are actually, I almost would ask you to come over to this mic because like
So my question is that, do you encourage new architectures? Right now the architecture for multipath is not deployable, right?
So, well, I would say not deployed. Certainly, yeah.
From our point of view, that in near term, I don't think Scion or Nira or Pathlet will be deployed. If that is the case, then all those questions will be less important if we don't have multipath available.
Well, I think that like, so question 8, right, is the one that that existing architectures have not yet answered, right? Yeah. To some extent, I don't think, like, so Pathlet, I don't know if there's a lot of stuff still going on Pathlet, so there's nobody who's trying to answer that question. I can't speak to Nira. I know that I work with the Scion people, right? So they're working on subparts. They're thinking about this one, right? But yeah, I don't think this is a venue for like, let's go pick up an existing path-aware networking architecture and make it happen. I think this is a venue, like new architectures are fine as well, right? I mean, obviously, it's, we're starting off from first principles, and if there happens to be, existing work from the existing architecture that fits into these first principles and answer these questions, then we should discuss it. But, I think that having this research group, define or, pre-standardize a path-aware networking architecture would be a very, very, very good outcome. I don't think we're there yet.
I'm asking this is because it's not very hard to design a new architecture,
right,
which can be a multipath support.
Yep.
But the problem is still deployment.
Right. Yeah. So I mean, like, I don't think we should spend a whole lot of time on defining a thing that doesn't answer question 8. That's why question 8 is there.
Okay. Yeah. Thank you.
Okay. So we are actually out of time anyways, yeah. But we just basically cut it into mic discussion, over mic time.
Yeah,
so like, go ahead.
I'm done. I was actually going to, I came into this thinking that I wanted to say, well, what's next for this document? Do we want to keep it open forever, or do we want to just go ahead and publish it? I think I've heard enough today that there's definitely at least one more rev of this that we need. And then I would sort of defer the question as to what happens to it to our next meeting.
Dr. Montenegro, yeah, on that topic, I guess that depends on what ultimately is the goal here. Do you want to also make this document sort of a reference, a collection of references of previous work? Because I can see elements of MIF, even there's V6 Ops is discussing stuff that is potentially relevant to this, like provisioning domains.
So I saw this with my, with my editor hat on. I saw this as primarily just a set of questions, right? Like, so then documents that tried to answer these questions would then point to other work, right? So we can talk about whether we want to actually stick the pointers in here or not. But my idea was that we could get to, at least these are the questions that we think we're doing, and then we sort of publish that, and then the use of that as an RFC is to say, hey, there's interesting research to be done here. If you've thought about these questions, please come to Panrg and discuss them or give us pointers to your thoughts, right? Because we're trying to pull all of this together. So that's again, my idea. I defer to my co-chair, who actually is the one who would actually talk about the scope of this document in terms of the RG, but yeah, if you have answers to these questions that aren't covered by an existing document, find people, submit drafts. Good. All right. So thank you very much. That was useful. Next is Spencer, right?
Yes, next is Spencer. Let me get the slides here.
You got to click that thing over there. Spencer, can you? No, wait. He hasn't asked to beam in yet. Can you ask to beam in so we can beam you in? Can I push the button? I haven't had a chance to push the red button this time yet. It's like, wow. Oh, there's sound effects now. That's awesome.
So this is me.
Hi, Spencer.
Hey guys, how's it going?
It's Friday.
I'm sorry to hear it. I'll try to be quick. So hi everybody. I'm Spencer Dawkins, and I'm talking about the bestiary of Roads Not Taken draft. So basically, things I wanted to say about that. Next slide, please. You guys have the, are you okay? Yeah, thank you. So this draft was an outcome of the first Panrg meeting at IETF 99. We keep encountering the same problems, so we should track them down. The idea or the plan was to not describe every idea, but capture every lesson. I want to remind people there is no shame in describing your learning experience, because this stuff was research, even if we were trying to engineer it in the IETF, and asking people to contribute subsections from your own experience, and then a little bit about how to do that on this slide. Next slide, please. So I've done the first major update, honestly, to this draft -01, just prior to IETF 102. I added pointers to IAB documents on protocol design and adoption. Thank you, IAB, for producing those documents. These are not specific to path-aware networking, but they're worth reading. I added section 2, which is a summary of lessons learned, that builds on new contributions, and I now have contributions on AntServe, Quick Start, TrickTran, which was there before, and Shim6, and provided by different folks. I want to get these descriptions right, so please send corrections. They'll be a lot more valuable if they're accurate. Next slide, please. So this is a summary of lessons learned, section 2, that's in -01. I have a question about what the right level of detail is. I have a section on lessons learned in each contribution, like if you look at 4.1.2 in the draft, and I have a summary section, section 2, and this is a summary of the summary section. So I'd like to understand where people think the right level of detail to include the draft is. But basically, these are the lessons that I've got. This is a summary of the lessons that we've learned from the things that have been contributed so far. The benefits of adoption must be big enough to overcome inertia. If you can't trust middle boxes can't help you. Benefits must be big enough for operators to justify deployment. Current operational practices can prevent deployment of good ideas. Per connection state and intermediate devices is an impediment. Increasing distance from sources of information makes path information less useful. And many applications don't know the things that they need to tell path-aware networking transports in the ideas that we've had on how to do this previously. Next slide, please.
I think, Brian, do you want to make a comment?
Did you, hi Spencer, Brian Trammell as an individual. Did you asked a question as to whether or not this was the correct level? Did you want that answered now or at the end?
I'd be okay with it at the end if people have ideas about that. And just to be clear, what I'm actually asking is the level of detail in section 2 in the draft the appropriate level? Because I've got more detail in the individual contributions, and we can certainly summarize the summary as I've done here. You got opinions?
I think section 2 is awesome, but I don't want to prejudice other people, right? Like, no, I actually, when I read this document, I was like, wow, that was more useful than I thought it was going to be, right? Like, so I actually turned it into a slide and started waving it at people. So, so I mean, it's all kind of blindingly obvious stuff, but it's blindingly obvious stuff for which we have sort of data, which is good.
Yeah, I was also pleasantly surprised, and I think this, this is blindingly obvious to everyone who's ever made these mistakes, but that's not everybody in the world or even everybody at the IETF. So I think it's more valuable than maybe we thought it was at the first meeting.
So I'm sorry, I'm not a standard academic. For me, blindingly obvious is not an insult; it's a compliment.
Okay. I spent too much time at the IETF. Sorry. Does that put us back on slide 5 then?
Yes. So
Oh, wait, actually, I think maybe backing up one from there. Okay, yeah, okay. I'm just
So this
getting a little bit. Yeah, you're in the right place. I just got lost. Sorry. So I wanted to think about what the goalposts for this document are. I'd like for it to be useful advice from Panrg to the IETF because of the things that Brian and I were just talking about, where things, we keep doing things like this to ourselves. The IETF developed all the protocols that are in the document now that were not implemented and deployed. There's no reason to think we will not learn these lessons again. So I'd ask for people to be thinking about what other guidance can we give to the IETF. I would also like this document to be useful advice to Panrg. The way I see this working, and I'll be interested in Brian's opinions, is that the open questions are there to guide Panrg research, and this document can help identify other open questions that would guide Panrg. So my question is, what other guidance can we give ourselves? Yeah, next slide. So, if I could, yeah. And the slides are painting slowly here for me. So thank you for being patient. I'm wondering if there are more path-aware networking lessons that we should be documenting. And part of that, but not the only part, is are there more places to look for lessons? I know that I'm looking at NSYS with Martin providing a contribution there. He just hasn't been able to produce that before the meeting, but there's always after the meeting. My inbox is always open. And I've got a couple of others that were proposed there that were not done in the IETF, but were proposals. And I can be looking at those to see if there are lessons that we haven't captured someplace else. Next slide. So the clues that I'm hoping to get as a result of this conversation is whether additional work on this document is valuable and whether adoption by the research group is valuable. This is, research group work in the charter that Brian was presenting earlier in this session. So that's kind of where I am right now, and I think I should be opening the floor up for people to ask questions.
Theresa Enghart, I have read the document. I found it really interesting already. I would like to see more content, and so I can answer both of these questions with yes, personally.
So actually, could I see show of hands who's read this document, or at least section 2? Okay, good.
Yes.
I even if you don't read the rest of the document, read section 2. It's pretty cool.
Yes.
You've already seen the slide.
Jen Linkova with no head. I actually read it and I really like it, so I would say it's definitely very good document. And yeah, I think we should keep working on it.
Okay, thank you.
Do you want to undo adopt? Yeah, undo adopt.
Yeah.
I think this was probably my opportunity to point out that this document is a lot better from 00 to 01, and that at least a major portion, if not all of the improvement, is due to text that was provided by other people. So, so as I say, my inbox is always open.
Okay, so in this case, please harm if you would like to see the document adopted by the research group. And please harm if you think it shouldn't be adopted. Huh? Clear?
Pretty clear.
Pretty clear. We still do it on the mailing list. I'll run call for adoption. Yeah.
All right, so
Okay, great.
Spencer,
So
next, once you arm twist Martin into writing something about NSYS other than just incoherent screaming, which would also be acceptable, then yeah, please submit the next one as draft IRTF.
I think that as an appendix to this draft, we should have a list of places where the support group for this work meets at each IETF meeting or IRTF Panrg session. But so I think there even primal scream therapy is part of the story that we're capturing here.
Cool, done. Next, what is next?
Thank you.
And next, thank you, Spencer. So next is lightning talk, I think. Let me find this slide.
That's, is the open?
Yes, it's open.
Yeah, Lynn Hun.
Yes, Lee.
It's Lynn that's doing the talk. Right?
Yeah.
So, good afternoon, everyone. Today I'm going to talk about topic about user interface for path-aware networking. We have three goals for this presentation. One is I want to show some challenge of password networking, and also we want to see if we can provide some multipass support in current internet. Also, for this purpose, we think we need a user network interface. So first of all, let's see what is the challenge of password networking. And we think it's a very big topic for this objective. And the first thing is that we lack of architecture that can really be accepted or deployed soon. Right now, we only have three proposals. Three of them are a pretty cool idea, but unfortunately, it's pretty hard to deploy in the internet wide. And we think we need more research to find the technologies can really support password networking in internet. Either we can use some, sorry. So we think we can either propose new architecture or by evolving the current internet architecture to provide the password networking feature. Second question we're asking is that can we support the password networking in current internet? And right now everyone knows that we can only use MPTCP in the current scenario which have multiple physical interface, such as Wi-Fi plus LTE or DSL plus LTE, which are really limited. And also, even for these two cases, we think it's not really can be completely support password networking. For example, the even two physical interface, if two paths is joined somewhere, then the MPTCP will not get higher bandwidth. So they do have some solution to support multipass in the current access network. List below are three drafts. And unfortunately, this three draft only describe the solution which is only limited in the access network. So our question is that what about one interface to user? Can we have a multipass support? And if the multipass is available in other area in the internet, can we support leverage it to support the password networking? So here is our thinking. We think is that definitely we can have password networking in current internet, but it's in some scenario. For example, here is a scenario which we have multipass available after the access network, which is very normal. For example, BNG or PGW. They normally have multi-home or multi-home support connection with multiple peers. And so for three segments, we only don't have we don't have the multipass available in the access network, but that part of the network normally belonging to one operator. So it can do some more work to support the multipass, such as provisioning or maintenance. And also, we think we need a new control protocol to really support password networking in this scenario. So if, for example, one operator owns the network from end to end, definitely operator can try to provide the multipass support even for one access interface. And also, this is very popular architecture in the 5G and beyond, because in the 5G and beyond, we service provider normally have edge computing or cloud-led connect direct to access network. So for that scenario, operator can try to change their topology or provision the network to provide the multipass support. And another popular topology that we have multiple operators. For example, the access network belongs to one operator, and the content provider belongs to another operator. Fortunately, even for this scenario, in the current internet, is that this big service provider or content provider normally have direct peering, or they are sharing the same internet exchange point. For that case, that from the one operator, it can easily figure out if it has a multipath connect to its peer. So what more work need to do even for this simple scenario? First of all is that we think the operator need to provision at access network. Right now, access network have so many technology used, such as Ethernet, MPLS, or IP optic. So network operator can definitely provide the more bandwidth to some user who wants the password networking. So why we want to do this is because the bandwidth for user multi-flows are constrained by the MPTCP fairness. Means that no matter how many flows you have, if they are sharing in the one bottleneck, their bandwidth cannot be more than one TCP session. So to overcome this difficulty, the network operator need to provide for that spatial user who want to use multiple paths to support MPTCP. So how to do this? They have different ways. As today the trainer also mentioned that use tunnel is one way, and also we can use the current technology. I mentioned the three technology to provide the disjoint paths in the access network, or even we can use the SDN to provision different bandwidths to a specific user. Also, I have another draft which will use the in-band syncing to provide the flow level QoS for the TCP. That can also be used. So for maintenance is that because between two network, if they are they have multipath supported, operator need to do maintenance to make sure that those multipaths are existed and usable. So right now, the different operator normally have a BGP multi-home connection, and they also have a multipath technology used inside the domain. So the operator, when they try to provide the multipath password networking, they need to maintain such a topology, and also they have to make sure that multipaths are disjoint and available. This is not just a teeny tiny work. They have a lot of research also associated with this. So for a baby step for this approach, we think we need user network protocol between end host and the operator. Then what is the purpose for this? First purpose is that, of course, to distribute the path property, such as segment routing information and other path information to end user before the real internet architecture can be can do such things. So second is that end user can tell operator what his service expectation, such as how many paths he want to use and bandwidth for each path. Also, we want to enhance the current data plan to support the password networking. Right now, we know that segment routing is one option, but segment routing, the stack is too high, especially for the wireless access, LTE stuff. That overhead is too much. So we think the end user should not use that much headers to really use multipath functions. So we may want to simplify those data plane. Maybe we want to have a new data plane to reduce the header stack. So in general, what the message will be exchanged is that we want to use the user service expectation. And also we want to have the distribution for the network information, such as the multipass and the pass property. This is falling into the question and answer for our research group. And also we want have the features such as to tell end user how to use the multipass. What is the data plane choice, either segment routing or other new data plane, which can be more efficient for the wireless. So that's my presentation.
And Dirk Kutscher, regarding the UNI idea, I mean, those who are old enough used probably UNI. Last one they were like trying to connect to ISDN. So the concept of UNI at that time was that you had your network and that got terminated, and then you got a very limited interface that allowed you to request a channel or access image control and so on. And so when we kind of went to the internet, we kind of had a different model. So in a sense that we didn't want to say prescribe where the network ends and where you have only limited interface for the say user or user equipment. So now here I see that you need some form of API or like discovery functions and so on. But do you also? Well, I'm not sure you really want to say describe this as a UNI. So maybe what we rather need is perhaps something sort of like management extensions or discovery extensions or so on that could be used, but you don't really say, okay, this is where the network ends and this is the user part that can make use of it. What do you think?
Yeah, actually, for this, we struggled quite a long time because this is two rush slides. I didn't show that is that we not only need the user network interface protocol or information exchange, we also need network to network. For example, here, the issue is not that simple. For example, let me see what is the slide here. So two segments don't have the multipass available. Only the middle has a multipass available because the asymmetric property of the IP pass. So we need to pass the user expectation to another end, which can program another pass. So for this, to make this work, it has a lot of things to solve. Definitely, we can change the interface or to other name, the user UNI to other name. I don't know if this one is interest to the group. If it is, then we can dig in more questions, problems, and solutions.
Right. So I mean, this raises more questions, to be honest, because I mean, if you now kind of say resurrect this telco idea of network-to-network interface, I mean, think this could be like a very complicated system in the end. So today we have the say IP data plane and we have BGP, right? Yeah. I mean, so and like deviating from that model, I mean there are many traps you can fall into. Is this really what you are proposing? So an NNI in the end?
Probably, because what happened is that fortunately this is a research group, so we think we don't have any limitation. Also, we think all these proposals will be much simpler than the new architecture such as the Scion or Lyra. Yeah, that's the bottom line.
Hi, Brian Tram. I'm going to try and do two things at once. I'm going to try and get Dirk to stand back up, just because I'm going to say something he'll disagree with, and I'm also going to try and to get this wrong enough that Aaliyah will stand up. Don't stand up yet. I haven't gotten it wrong yet, right? So I agree with most of what Dirk said about, we have, the internet end-to-end model, and that has really, really, really nice properties. And that by explicitly adding back to the architecture sort of a UNI and NNI concept, that we kind of blow that end-to-end model up. At the same time, what you're not showing here is all of the tunnels that implement that.
Yes.
So, you can say option. Well, so tunnel's just one option, and then the other option is a tunnel, and then the third option is a tunnel. There are various encapsulations that are used to make this all work, and whether you think they're tunnels or not, they kind of have tunnel-like properties, right?
Yeah.
So, I'd like to take this idea and I'd like to kind of hit it with a hammer and have like the good part fall off. I think if you go to the end, your last slide. Who's got the? Oh yeah, can you go to? Yeah, so keep going forward. Yeah, so when we talk about, so the purpose. One thing I like here is different data plane support, right? Like so. To some extent, if you are, using, so my wonderful vision is that we actually can evolve the internet in some unspecified way that, answers question 8 correctly, and you end up with multiple data planes, all of which are going to somehow be encapsulated in segment routing in MPLS over IP, over whatever, right? Just that's how we evolve the network, is overlays on overlays on overlays, and eventually look at jumbo frames so that we can actually use all of that for encapsulation overhead. The thing, so I would think that what might be useful here is something that isn't an explicit UNI, but is basically a way for you to be able to tell an endpoint that that a user, an end user device or a server could connect to some sort of thing that is basically a tunnel broker that's doing this data frame stuff and talk to that about the properties that it wants in terms of these pathways. And now Leah gets up. Yes. Achievement unlocked. And so like basically saying, okay, well, we're going to put the UNI and the NNI concept back in. I don't think that is a great idea. I do think that defining the vocabulary for this interface where you could talk to a tunnel endpoint and tell it what kind of path properties you want is probably not a bad idea. I think we can think about that. I think that kind of comes out of, if going back to the questions wrap, that comes out of the question 1 and 2 work, right? Like how can we turn this set of possible path properties into an information model that could feed into a protocol like this? Yeah. And that actually is maybe like a something of independent utility that we could throw back over the fence and say, okay, IETF, go do this. Yeah. And then Aaliyah will AD sponsor it. Oh, wait,
no, I can't anymore.
Sorry. All right, so that was my piece. Yeah, okay, thanks.
Yep, thank you.
Chun Xiong from Hawaii. I'm working on the 5G in 3PP. One of the basic ideas is that the network does not fully trust the user provided information like the service expectation, because some user can always provide a prime service expectation, even he has a best effort service. So from our 5G network point of view, we only trust the service provider or content provider provide service representation, because we have 5G network operator can have a good SIA, for example, like Google or Alibaba or Tencent. We have agreement that we trust this service provider. So in such case, we only trust the information provided by this big service provider. So in such case, we have defined some, we say, rough band interface or to negotiate such service competition between the 5G network and the third-party service provider. maybe in this action, I think maybe you need to can pay more attention for this direction.
Sure, yeah.
Hi, Leah Atlas. For thinking about this for the MPLS or segment routing related pieces, one of the things that's being done is something called TE policies, which is in BGP where you can have the communities. And one of the things because a segment ID is being used as a, basically it's an arbitrary identifier to say a way to get from here to there or this particular resource or so on, that you might think about that as a kind of abstraction where the user, for your interface, you might be able to say, I want a label that indicates these path capabilities, and then it gets brokered to the appropriate TE policies at different ASNs. I mean, there would be work to be done there, but you could see sticking a well-known kind of, this is a user one, here's a well-known segment ID that indicates the type of path, and then at different points maybe be able to look up and do the translation. There's a lot of different ideas of taking a segment and then tying it to either a full OSP or a longer path or so on. So there's some routing mechanisms that you could play with. But yeah, I mean, as Brian says, it's tunnels all the way down.
Yeah, we haven't thought so much. Actually, for our initial thought is that, first of all, we don't want to introduce any new protocol. We want to extend the current user protocol because we learned the lesson that desktop cannot have any other protocol except some fundamental protocol such as DHCP or something else. MPS or all those complicated routing protocol, we don't think will get to end. So for all those information, no matter if it's tunnel related or the network related, I think we can use some existing protocol to transfer between user and service provider.
It's not just one service provider. You can't just go to one service provider and say, here, this is what I want. And the question is, do you have a description on the packet saying what you desire? Do you assume that either you tell your local service provider, this is what I want, and whenever it goes to the next service provider, it all gets zeroed to best effort? Because that's the default.
Yeah. So come back to that question. So I think all this information changes. For example, after user is authenticated to the one service provider, then if this user can get all those expected service, it's up to their SLA. So they can, for example, I got my LTE service with so much bandwidth, but for my next TCP session, I want some bandwidth guarantee service. For example, from tabs or intent information, then sent to the service provider. We don't want to have a kind of permanent tunnel established before the end user gets the all service. We want to have a kind of per service based service expectation. Flow based. For example, I have a new TCP session. I want to have that TCP session has so much bandwidth, something like that.
So, TCP sessions don't get reserved bandwidth, right?
Yes.
I mean, that's a whole different type of problem. There's a difference between I have this much access and I'm actually going to get bandwidth guaranteed across a path. But one of the more critical things is the way that you are thinking about tunnels is as something that takes time to set up, as something that has control. The difference with MPLS and with segment routing is that goes away. It doesn't take time. Throw 32-bit, well, 20 bits plus, throw your label stack on and off you go. You don't have to have setup time. It doesn't have to look like an interface. It can just be, this is how I want to go, directive, and off you go.
It could be an option into the socket that tells you which path direction and to put the correct label stack on. I mean, don't assume, oh, tunnels mean it takes time. It doesn't.
Okay. Yep. Okay.
Thank you for the work. It looks interesting.
Okay.
No more comments, and then we have, thank you very much. So we have open mic discussion, so any comments, suggestions, topics, complaints?
Tommy. So just based on some of the things that we actually just saw here about when we're talking about deployability and the fact that we have one interface or multiple interfaces, I was thinking, of course, about some of the work that we're doing on PVDs, in which it would allow us to, through one physical interface, of course, have things that can be represented as virtual interfaces or essentially different local addresses that have truly different meanings in different provisioning domains. And so I was thinking, like, this is essentially, would it be useful to have a distinction in our terminology as we're talking about the different paths, also of things that are different paths because they have truly different provisioning domains and they cannot, like, we are kind of guaranteed that these are really different paths all the way down, even if they are purely, if they don't relate to like a physical interface, as opposed to things that we think are paths that are more just like a routing equivalence that we may want to toggle somewhere down the network, but are equivalent from the perspective of the services that they offer. So I don't know if it, I'm not necessarily just saying we should incorporate provisioning domains as a top level thing here, but we should think about how paths are equivalent to interfaces or equivalent to just paths that are down the road.
Yeah, can I rephrase that question using entirely different words to see if I understand it? Paths have path properties as we think of them sort of in the history and the transport layer of being, like latency loss, like things we can measure, things we can know, or things that we need to know in order to schedule a packet, right? Like, so these are all basically just inputs to a packet scheduler, right? And they also have topological properties. And they might also have a third class of property, which is fuzzy. It's a fuzzy sort of constraint based on the, you know what, actually, I don't understand this. Can you
Is that third property what you're referring to is like what I was saying for the provisioning domain?
Yeah.
Right. So saying that there's a fundamental difference about what I'm able to do over this network potentially, and maybe they can link up at the end of the day.
Yep.
And I can actually do multipath over them, but I have knowledge that, oh yeah, this, because the classic example of a different provisioning domain that we have today is like a cellular APN that's actually routing you through the carrier because you want to specifically have it have some service. And so this is not just about I want to get different latency, I want to get different quality, but actually I want it to be observed or go through some other boxes that are not available elsewhere.
This is amateur packet radio, you can't put commercial traffic over it, and so on and so forth. Right. This is satellite radio, you can't put treaty violating traffic over it.
So it seems like it could be a dimension when we talk about paths being different.
Is that a thing that you can form in the form of a question that fits in the questions document?
Potentially. So I can look at it, is this a question?
Yeah.
What are the different categories of paths?
Question to Tommy, is this a question?
I don't know.
Argumento Negro. So I'm trying to understand how, what the scope might be, and if the answer is the questions document is pretty much done, might want to add that to the charter, because that's very helpful guide for people to come in and look at.
That's an interesting feedback. Yeah. So,
But then I have another question that might want to make you reconsider that. The other question is, I was trying to wrap my head around implications of those questions, the existing questions, and what popped
in my mind was, what is the relationship, if any, between this and network slicing, especially when you take into account questions 7 and 8?
I'm sorry, that was a question. I wasn't prepared for a question, right? Like, so what was the beginning part of that?
What, if any, is the relationship between Panrg and network slicing, especially as you take into
slicing.
account questions 7 and 8, the operator involvement?
Right. That's a good question. Well, I think that, yeah, so, and I'm up here because I'm an individual, I'll make that clear. So one of the interesting things about this, this presentation was that, like, sort of the first slide is like, yeah, here's how it works in a single operator scenario, right? And like most of the 5G work is being done in the context of a single operator scenario. And that turns this into it actually maybe turns this into not a research question, right? Like you can do all of this stuff on your own network pretty easily, right? Like it's Spring, we've done it, it's shipped, it's as many tunnels as you need forever for free. And yeah, there's not research. The real thing that changes this is in an interdomain scenario where the interdomain scenario really is an interdomain scenario. We're missing this as Dirk said, right? We're missing this network interface. Right? How do you do this in a world where there's no network interface or no common, right? Like, so is there stuff that flies out of this that could inform slicing or come up with ways to do slicing with a business model that isn't a single operator business model? Maybe. I don't know. That's a good question. We should think about it.
Any other topics? Questions? Okay, then please think right now if you have signed the blue sheets. If you have not, please raise your hand and they will be delivered to you. Okay, thank you and see you in Bangkok. And think about topics we could talk in Bangkok, please. Start right now and we'll set the call for agenda items later.
I'm interested, but I think if I sign up for a work, or acquire a gibbet and then string. Right.
Okay, so Brian, where are you leaving now? Because I'm leaving now.
Yeah, you're leaving now.
Yeah, I'm leaving now. So see you in Amsterdam.